Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X Approaches Earth, Geomagnetic Storm of August 25th, 2018. Now, on August 26, 2018, the Earth was hit by a strong geomagnetic storm, which resulted in bright auroras. The event had not been predicted and was thus a surprise. According to spaceweather.com, a minor CME hit the magnetosphere some 24 hours earlier, and it hardly registered as anything of any significance. But right after the CME passed, the Earth's magnetosphere experienced incoming solar wind with a suddenly strong south-facing magnetic field, which opened a hole in the magnetosphere and allowed solar wind particles in. This then led to the geomagnetic storm. However, the storm continued into the 27th after the effect of the hole in the magnetosphere opening should have ended. So on the 27th, spaceweather.com reported that the Earth was going through some fast solar wind, coming from a coronal hole in the Sun's northern hemisphere. However, the solar wind speed was not fast enough for this to be the cause behind the geomagnetic storm. And here we see what happened with the KP index. And first, starting with the 25th, you can see the KP index rose slightly from 1 to 2, from between 5 and 16 UTC. So this was actually the very small CME hitting the magnetosphere. And then it went down, and then it went straight up again. It started going up at the end of the 26th, and it went all the way up to a KP index of 7 at about 6 UTC on the 26th. So this was when that strong and very surprising geomagnetic storm occurred, which then led to auroras. Now, as you can see, the KP index of 7 from this table means a strong geomagnetic storm. The index goes up to 9. Now, this is the data from the Corona magnetogram, which here is also given in terms of a KP index. And you can see what happened on the 25th. This is the data from the 25th. So the KP index rose from 0 to 3 on the 25th, and that would have been the small CME hitting the magnetosphere. Then after that, we start with what happened on the 26th. As you can see, the KP index goes all the way up to 7. That's a G3. On the 26th already, as far as the Corona magnetogram data is concerned. Then on the 26th, we can see the Corona magnetogram data tells us that between 3 and 6, the K index went all the way up to 9, which means a G5 geomagnetic storm, the strongest possible. It then went down, and then it rose again, and that went on into the 28th. Now, so what caused that type of geomagnetic storm? Well, if we look at the solar wind, here it is on the solar wind density. On the 25th, it went up to just above 25. On the 26th, it just rose slightly above that. So this is the 25th during that very small CME. So that means that very strong geomagnetic storm couldn't have been on the 26th, couldn't have been caused by solar wind density. It was just tiny bit higher than what it was when we had this very small effect due to that CME. So it couldn't have been the density. If we look at the solar wind speed, it rose, it never rose above even 500 just about slightly above 550 on the 26th. So that couldn't have been it. And on the 27th, it rose to just about 650. It's still too slow to be fast solar wind. Fast solar wind speed is 800 kilometers per second and above, or at least twice as fast as the normal solar wind speed. So at no time have we actually seen fast solar wind. Now, the magnetic field data shows a strong magnetic disturbance between 6 and about 18, actually even before that, because it's only strong enough when this is red. The red is the Z component of the magnetic field, the Z component of the magnetic field. And when it goes below minus 10 nanotesla, then it is possible that a small hole can be opened in the magnetopause. And that then allows solar wind to get into the magnetosphere. So this may have been what led indeed to that aurora. But as you can see, by the 27th, that had died down. So it couldn't have been the magnetic field. In fact, on the towards the end of the 26th already, the Z component did not go down to minus 10 nanotesla. And we can see that the Z component, the Z component of the magnetic field is along the Z direction, which is the north-south direction. And when it's negative and below minus 10, it can make a connection with the Earth's magnetic field at the magnetopause and open a hole in it. But it's only if it gets close to minus 20 nanotesla that we could possibly get a G5 geomagnetic storm, which is what Corona detected. So the Corona magnetogram registered a G5 geomagnetic storm, and yet the ACE data does not show the Z component of the magnetic field going or reaching minus 20, going past or reaching minus 20 nanotesla. So you can see it hardly reached minus 15. So not high enough for a G5 geomagnetic storm. So this suggests that the larger part of the magnetic field which went on to impact Earth was missed by the ACE spacecraft. In other words, the magnetic field was not generated by the solar wind particles or the coronal plasma streaming past the spacecraft, but was most likely generated by a solid object moving with the solar wind. This object's strong magnetic field would have influenced the solar plasma around it, but the further this plasma was from the object, the lower would be its magnetic field. Thus, if the object passed some distance from the ACE spacecraft, the coronal plasma streaming past the spacecraft would have had a lower magnetic field than the coronal plasma closer to the object. In addition, the fact that the magnetic disturbance came after the CME suggests that what actually occurred was that a stellar core came toward Earth behind the CME. These objects are usually seen moving away from the Sun within CME material. Stellar cores actually seem to cause CMEs and also seem to be ejected away from the Sun with the CME plasma. So it's not surprising that one of these objects would be coming along with CME plasma. And you may see Article 1 on interplanetary climate change entitled The Sun for more details. Stellar cores, which are also brown and black dwarfs, have high magnetic fields and so are likely to disturb the Earth's magnetic field. And you may look at Article 317 entitled Planet X System, Brown and Black Dwarfs with High Magnetic Field for more details. And here we see one of these stellar cores moving away from the Sun within CME material. And this often occurs because they're actually the cores behind the CME. They actually cause these CMEs. So we can also see lots of debris, and these objects generate the debris because they share their outer layers of material. Now, the debris would not have a high enough magnetic field to cause this magnetic disturbance. That's because they don't have the debris does not have a core. Only a stellar core or an old star or planet with a solid core would have a strong enough magnetic field to cause such a profound magnetic disturbance to the Earth's magnetosphere. This therefore indicates that a stellar core approached Earth on August 26, 2018 and caused the surprise geomagnetic storm that day. The geomagnetic storm conditions, which were apparent on the 27th of August, could not have been caused by fast solar wind because the speed of the solar wind never went close to 800 kilometers per second. This suggests that perhaps large amounts of stellar core debris, which may have come with the stellar core on the 26th of August, may have stayed around Earth. This debris would then start absorbing energy, which would ionize the ionosphere and thus create geomagnetic storm conditions. The stellar core most likely went back towards the Sun, or we would continue to detect magnetic disturbances on the magnetosphere. Larger debris pieces may have entered the atmosphere as well. These larger objects will create a strong electrical interaction which may look like a meteor exploding in the atmosphere if the energy transfer is strong enough. In conclusion, the surprise geomagnetic storm of August 26, 2018 seems to have been caused by a stellar core coming in behind the CME, affecting the Earth's magnetosphere. The continued geomagnetic conditions, which continued until the 28th of August, were likely to have been caused by stellar core debris, which may have accompanied the stellar core. This stellar core must have come very close to Earth. It was not possible for the continued geomagnetic conditions on the 27th and 28th of August 2018 to have been caused by fast solar wind, as the solar wind speed did not reach a high enough speed. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.